Hello, my esteemed viewers. This is Medical Science Lecturer. Today I'll be discussing with you incline vectors. Remember that you need to check for my videos on parallel vectors, perpendicular vectors. It is important because those videos will provide you foundation to understanding the topic what vectors. But for today we'll be looking at what incline vectors. Now, when do you say that vectors are said to be inclined? I told you what you will see when you see a vector and the vector is perpendicular. When to say if vectors are perpendicular, when to say vectors are parallel. And now today I want to inform you, I want to tell you how to know that a vector or the vectors or the equation given to you is a case of inclined vectors. Now, you know that when vectors are this way, let's say this is a vector and this is another vector. This one, the vectors are said to be parallel because they will never meet each other, and because they cannot meet, no angle will be formed between them. You now say these vectors are what? Parallel. I told you, and in my video I've discussed how to find the resultant of this system of vectors. Now sometimes also a vector, one might be running like this and another one will cross it, such that an angle of 90 degrees will be formed. Once you have that, this becomes what? A perpendicular vectors. I have a video, I have equally discussed in that video how to find the resultant of perpendicular vectors. But today, this discussion is on inclined vectors. When do we say a vector? Vectors are said to be inclined. Now, if I have a vector, let's say this vector is going this way, and I have another one, let's say this is inclined, the angle here, let's say is 30 degrees. If I have this, and they say this is vector A, and the magnitude of vector A is, let's say this angle is theta. The magnitude of vector A is VA, and this is vector B. The magnitude of vector B is, let's say, VB. Now, supposing we have something like this, now these are two vectors. Just like here we have two vectors. Here is vector A, here is vector B, and this one is moving this way, and this probably is moving this way. You can see that this is moving this way, this is moving this way. They are parallel, they will never meet. And because they will never meet, then you say this is what a case of parallel vectors. But for this, also for this one goes this way, while this is going down. This one now meets this one at this point. At this point, for this, there is a meeting point. But the meeting point gives you an angle of 90 degrees, for which we say this is what? A case of what? Perpendicular vectors. And how you solve it is different from how you handle this one. But for inclined vectors, now in this case, you see that this vector is this is the vector, this vector and this vector are meeting at a point. And the meeting point gives you an angle theta. Obviously, this angle theta is not 90 degrees. Please take note, this angle theta is not 90 degrees, because if it is 90 degrees, it will therefore be a case of perpendicular vector. So this is a case of inclined vectors. So how do we solve it? What I want you to know, once you have an inclined vector, and I said an inclined vectors are a system of vectors where the angle between the two vectors are not equal to 90 degrees. In most cases, this angle theta, which is of course the angle formed between the two vectors, will be less than 90 degrees. It's less than 90 degrees. Now, how do we get the resultant? Quickly, when you have a thing like this, please, this is what you need to do. Please know that this must be transformed to what? A mathematical shape. A mathematical shape or figure. So what I'm going to do is that I will construct a line here, and I will construct another line here. Having done so, you notice that we now have a four-sided figure, a four-sided shape. And now, with that, you know that if I draw a line from here to here, that line becomes a diagonal. If I draw a line from here to here, that line becomes a diagonal. But according to parallelogram law, this diagonal should be considered the resultant. This diagonal should be considered the resultant. So if I draw this line, I will now say this is what? The resultant. According to parallelogram law, when you have a four-sided shape, the diagonal, which of course is called the leading diagonal, represent the resultant of what? That system of what? Vectors. So now I will need you to understand that if this is a resultant, remember that this is a parallelogram. the opposite side of a parallelogram are always what? Equal. Therefore, if here is VB, here will equally be what? VB. If here is VA, this one will equally be what? VA. Remember again that if here is theta, please take note, very important. If here is theta, this other angle will be 180 minus theta. Why? Because the opposite, the base angle of what? A parallelogram are supplementary. What that means is that this angle plus this angle must be equal to 180. Therefore, if we've gotten this angle, for you to get this other angle, we need to do what? Minus we'll use 180 to minus what? The theta. So the sum of this angle plus this angle must be equal to 180. So which is why we say base angle of parallelogram are usually what? Supplementary. Now you can now see that we have two triangles in this case, two triangles. If I decide to remove now you can see that this one now is the same thing, and opposite angles are equal place. This angle is facing this one. So if here is 180 minus theta, here will be 180 minus theta. If this one is theta, this will equally be 1 theta. The opposite angles are equal. The opposite angles are equal, but the base angle are what? Supplementary, and then the opposite sides are what? Equal. Now, because we have two triangles here, if I decide to remove one of the triangles, I will have something like this. Where here is VB and here is what? VA. Remember that this angle is 180 minus theta. Now remember that this is what? The resultant. Here is, now you watch and see that this angle now, theta, represents the whole of this. But now you have this line we only extracted from here. So I can say that here, let this angle be what? Alpha. Please, this angle is alpha, of course, which is this angle. Now, what do you see? In this case, you will apply your cosine rule. Your cosine rule, or what we call the sine rule. Cosine rule or sine rule. You either use the cosine rule or sine rule to solve these problems. Remember, if it is perpendicular vector, you apply what? Your trig ratios, which is sine theta, cos theta, tan theta. If it's parallel vectors, remember, what do you apply? Just the summation. You just need to sum the given vectors. But for incline vectors, what you're supposed to do is to do what? To apply your cosine rule or your sine rule. Please take note. It's not every triangle you see that you apply your trigonometric what? Ratios. Trigonometric ratio can only be applied to triangles that are right angle triangle. But when you have a triangle where none of the angle is 90 degrees, therefore you cannot apply your trigonometric ratio. I can't apply trigonometric ratio here. What I can possibly apply here is what? Your sine rule or cosine rule. Now, if in this case we have an assumption, the assumption is that this side VB is given, VA is given. In case you have a, supposing this equation, we have this given, this plane is given, this angle is given, but this is not given. We are to find the angle R, the side R. Now, you can apply your cosine rule. Cosine rule, normally, you apply cosine rule when two sides are given and the angle between the two sides is also given, then you can apply cosine rule. Look at this case. In this case, VA is given. We assume VA is given. Place VB is given. I may say here is 10 kilometer. Here is 30 degrees. Here is 120 degrees. Here is 120 degrees. It means, therefore, that this side is given, this side is given, and this side is given. So, please, I'm assuming that VB is given, VA is given, but this is not known. So, if I want to find this, because the whole essence of this explanation is how to find the resultant, where the other vectors must have been given to you. So in this case, the other vectors are vector A and vector B, and their magnitude are what? A and B respectively, VA and VB respectively. The angle between them was given from the beginning to be what? Theta. But you now need to say 180 minus theta. So if this was maybe 30, if this was 30, here would have been what? 180 minus 30. Of course, 180 minus this would have been what? 150. So please, emphasis is on the fact that this angle is known, this side is known, this side is known. And I want to go ahead to find what? This side, which is what? The resultant. And remember how we arrive at this, where we say we have to draw this line, you draw this line according to what? We just need to construct this line so that this will become what? A parallelogram. And when we have a parallelogram, we now say this diagonal will represent the resultant. Haven't done so, we now say, okay, let's remove this other triangle, because this triangle is the same as this triangle, because this angle is the same as this angle, this angle is the same as this angle, this side is the same as this side, this one is equal to, so this triangle is exactly the same as this. So we cannot be using the two of them, we have to take one, and that I chose this other triangle, and this is what we now have. Now I want to now apply cosine rule. Supposing we want to apply cosine, this is what cosine rule says. Cosine rule says that the square of what? The hypotenuse must be equal to the square of VA plus VA square, that is the square of this side, VA I want to apply the cosine rule. So cosine rule, I want to apply the cosine rule to find what? The R. That would be what? R square equal to the square of this VA square plus the square of this VB square minus 2 times VA VB cos this angle, which of course is cos 180 minus theta. From here, you make what? Your R the subject of the formula, wherein you know that this will become R equal to the square root of all of this. But remember, if here is 150, therefore this will be cos 150. Please take note. If here is 120, therefore here will be what? Cos 120. If here is 5, if this was 5, we would have placed here 5. And if here is 3, we would have placed here 3. And then go ahead and you have the final answer. That is a cosine rule. I repeat again, the condition for you to use cosine rule, you don't use cosine rule at all times. It's only when the condition is enabling. For example, for cosine rule to be used, two sides must be given, and the angle between the two sides must also be given. Now, here, this is one of the sides given, this side is given, the angle between is also given. Supposing this angle is not given, I cannot apply cosine rule to find this other side. So it therefore means that if I want to find, supposing this side was not given, and I want to find this side, then this side must be given, this side must be given, this angle must also be what? Given. That is the rule for what? Cosine rule. If that doesn't happen, then you need to use what? Sine rule. You need to use sine rule. And what the sine rule says, this is, please know that this is cosine rule. For sine rule, what you do is that you consider the requires the side you are interested in. In this case, I'm interested in what? This side. So I will say R all over the angle that faces it. That is what? All of sine 180 minus theta. The R, which is the side I'm looking for, all over the sine of its own angle. And so its own angle must be the angle facing the side. And that side angle is 180 minus theta. So if here is 150, this would have been sine 150. If here is 120, here would have been sine 120. So the idea is that the side you are looking for, all over the side of that angle, the angle of that side. So this must be equal to, now, VA, if I say VA here, VA must be equal all over sine the angle of what? VA. The angle of VA has to be the angle that faces what? VA. You can see in this case, we do not have any angle here. So if I say, for example, let this angle be beta. So this would have been sine beta. And that has to be equal to VB all over sine, this is, if I'm using B now, the magnitude B, the angle that is facing the magnitude, the B is what? Alpha. Therefore, this has to be what? Sine alpha. All over what? Sine alpha. Why this is what? Sine beta. So I take that again. The idea is that for sine rule, for you to apply sine rule, every side you're interested in, that side must be dividing what? It's at the side of what? The angle of that side. So for instance, we are taking R. I want to find R. So R, which of course is the side, has to be all over sine of the angle that is facing the side R. That has to be equal to VA all over the side of the angle of what? A. And that angle is what? Beta. You see that this is A, VA, and VA is facing this angle beta. Therefore, it has to be the sine, or all of it has to be the sine beta. equal to VB all over sine what alpha, where alpha is this angle that is facing what? Facing what? B. So that's how it is. So, but when you're solving, you either take two of this. In this case, we're interested in what they are. So I will either take this, or I will take this and this. I will have to combine the required side, the required fraction. This case, the required fraction is this one with the other fraction that is known. So I'll be looking at between these two, which one has is completely given. If VA is given and and B is given, then I will combine these two and look for what R, where I will make R the subject of the formula. But the idea is that the side you're interested, the fraction, the side you're looking for, or the angle you are interested in, that fraction must be maintained, and then you combine it with another fraction that has every parameters given. So this is actually how to find incline vector. It's very simple, but I want you to understand that it's not anytime you have a vector question, what must come to your mind first? What system of vectors do you have? Is it parallel vectors? Is it incline vectors? Is it perpendicular vectors? Now, each of them has its own way of solving them. So that's one thing I want my viewers to understand. You don't just begin to solve, except you have justified that what you are dealing with, this fits into a particular system of what vectors, and then you have to recall everything that you know about that system of what vectors. For this in this case, we have what is a case of what incline vectors, where you have to apply your cosine rule or your sine rule. I have told you for perpendicular vectors, you rather will apply what? Your Pythagoras theorem or your what? Trigonometric ratios, where we talk about sine, theta, cos theta, and tan theta. But you don't need to apply that here. Now for parallel vectors, you're going to apply what? Algebraic is simply by adding the given vectors. Very simple. So which is why I request that you look for other videos of mine concerning what parallel vectors, perpendicular vectors, and even the introductory video on vectors. So I've equally done videos on physical quantities, where we discuss fundamental quantities and derived quantities, and very many other topics. So I request that you subscribe to this channel, so that anytime new videos are made, you'll be first to be notified. Again, like this video if you find value. Thank you.